All right, ladies and gentlemen, our topic today is on similar figures. Some of you might be thinking, but Mrs. Ott, that is a geometry topic, and aren't we in, unit rates and algebra and proportions and all that kind of stuff? Well, yes, we are, but we are going to use what we know about proportions and rates to understand some things about similar figures. Please put the heading and the date, which should say November 18th, 2013. You should be on page 67. And our objective today is I can identify similar figures. You really should already be able to do that based on previous years. And calculate the scale of similar figures. Scale, where we find the scale of the two similar figures, that's where we start dealing with things like unit rate and proportion. So that's where our current unit fits into this kind of geometry sounding unit. So on the same page, let's look at an example of some similar figures and talk about what the definition of a similar figure is. So any two or more figures that are the same shape but different sizes. So if you look at triangle ABC and triangle DEF, they are the same shape, but clearly they are different sizes. If I took triangle ABC and I just made it bigger, it would be the same as triangle DEF. But for now, let's keep it small. Okay, and with similar figures, all of the side lengths are going to be different. Let's say this is an isosceles triangle, so these two sides are congruent. Let's say that side's 4 and that side's 4 and this side down here is 2. When you make that shape bigger, keep the shape, increase the size, you're still going to have an isosceles triangle with two equal sides. And let's say this time that the side lengths are 8, 8, and 4. We have increased this smaller triangle by a scale of 2. Every side I doubled in length. We're going to be figuring out how to find what this scale factor is on shapes that aren't quite so, nice even numbers. So to calculate the scale factor, write this down on the same page. If you run out of room, you can go ahead and go to the next page, but try and get it on page 67. The first thing we need to do is identifying the corresponding side lengths. So in this example, it's pretty simple. If I look at this side, side DE, it's pretty obvious that it corresponds to side AB on this triangle. They're both kind of pointing in the same direction, so it's easy to tell what's corresponding. It isn't always easy to tell what is corresponding. The second step, we're going to choose one of these pairs of corresponding sides. You only need one for this. Once you know it's a similar figure, you can just find the scale with one pair of sides. So let's use these two sides that I just marked, DE and AB. Our next step says to create a ratio of the larger side to the smaller side. Okay, so then we have to figure out which one's bigger. Is DE bigger or is AB bigger? I really hope you told me that DE was. And then we're going to make a ratio of this side length, which is 8, to this side length, which is 4. So if I kind of write this out, it would be the ratio of line DE to the line AB. Okay, that's how you write a line segment. And it's going to equal 8, which is the length of DE from our previous example, and then 4, which is the length of AB. Step 4 in this process is to simplify the ratio until it has a denominator of 1. That denominator of 1 should give you the heads up that we are finding a unit rate. So all we need to do is take our numerator, which is 8, divide it by our denominator, which is 4, and we find out that the scale factor here is 2. Okay? So just like we noticed earlier, you take each side length, multiply it by 2 to get to the larger side length. We have now shown that the scale factor is definitely 2 by doing the calculations. Please make sure you wrote all of that down, including labeling the all the side lengths here on these two triangles and labeling the triangles ABC and DEF. All right, so let's look through a couple examples. You can put this on page 68, and once again, put the date November 18th, 2013. And the shape that we have here, it's a five-sided shape, and that is called a pentagon. Hopefully you knew that. In this pentagon, it's a regular pentagon, so all of my sides are equal lengths in each of my figures. Do you know why I'm doing these double lines here? If I were doing single lines, then it would be saying that this side length is the same as all of these. And that's not true. So one single mark, one single hash, as we call them, mean that all of these five sides are equal, and a double hash means that these five sides are equal. So first thing we need to do is we need to identify what our corresponding sides are. So let's go ahead and label these pentagons. We have A, B, C, D, E, and just for fun, let's start at L, M, N, O, P. So this first line here, line AB, is going to correspond, we use that symbol, an equal sign with a little wiggle, to the side length PL. And then we have BC, we can just work around our shape here. BC corresponds to LM. Side CD right here is going to correspond to MN. Once again, this is nice because the two shapes are in the same kind of orientation. One's not tilted in a weird way. And then two more, we have line ED, which is corresponding to line ON. And finally, EA corresponds to line OP. Make sure you write all of that down. Now to find our scale factor, we need some numbers on these shapes. So let's say in this little shape, one of the side lengths is 10 centimeters. The nice thing about these little hashes on the shape is that we can tell what all of the side lengths are. Excuse me. So if one of these is 10, all of the other ones are going to be 10 centimeters as well. And then if we look at this larger pentagon, let's say that one of my side lengths is 16 centimeters. So that means that we're going to make all of these side lengths 16 because those double hashes tell us that they are equal. If we look back at our notes for what to do then, we have to choose one pair of corresponding sides and create a ratio of the larger side to the smaller side. So let's go ahead and choose side MN, which we found corresponds to side CD right here. And we're going to make a ratio of the larger side to the smaller side. So that's going to be 16 over 10. The instructions then say that you have to find a unit rate. Best way to find a unit rate in this case is to just divide the top by the bottom. And when I do 16 divided by 10, I get 1.6. So our scale factor is 1.6. You might also see this written as 1 to 1.6. Okay, that's another way you'll see scale factors written. You'll see that a lot on maybe a map where you have to find the distances between cities and they'll tell you what the scale factor is of that map. All right, let's do one more. This time it's a little bit different. This time my two shapes are tilted from each other. This shape has four sides. One set of lines is parallel. That's what that little arrow means. And then we'll do two little arrows here to show that those are parallel. And then the other sides aren't. This is a trapezoid. So let's call these trapezoids. We'll say this one is F, G, H, I, and Q, R, S, T. And I'll throw some side lengths in here. That'll be 16. This will be 8. That will be, let's call it 9 and 9. And then I'm only going to give you one side length on this smaller trapezoid over here. I'm going to say that this base, the longer base, is 3. Okay? So we need to calculate the scale factor of these similar figures. The corresponding sides, this is the tricky part. Because the shapes are turned, you really have to kind of think about the sides in a slightly different way. So I'm going to start with this large base. We have side FG. And we need to ask ourselves, what side on this smaller trapezoid kind of matches up with that? Well, it's the longer of the two parallel lines. So the longer of the two parallel lines here is RS. So we know that FG corresponds to RS. Okay, so we've taken care of that and that. We can then take the other parallel line. We'll do HI is going to correspond with the other parallel line in this trapezoid, which is QT. And then we have these sides to deal with. I'll put little check marks here because we've used those. We have these sides, okay? So ST, if we look at our parallel lines, if we kind of mentally turn this shape this way a little bit so that it kind of matches up with the same angle as the larger shape, ST is going to correspond with GH right here. So ST, the line segment ST corresponds with GH, and that means the only ones we have left are QR, which corresponds with with FI. All right, make sure you've written all of this down, guys. Now to find the scale factor, we choose one of our pairs of corresponding sides, but I only have one choice here because this second shape only gives me one side length, a side length of 3. So I have to use the sides RS and FG right here because those are the only sides that I have enough information for. I'm going to make a ratio of the larger side to the smaller side, and then that is going to give me a scale factor of 1, 2, 16 divided by 3 is 5 1/3. So our scale factor here is 1 to 5 1/3. I want you to try to do this reflection. I'm going to label the sides A, B, C, D, and E, F, G, H. We'll say that these lengths are 8 and 2, and we'll call this one, I'm only going to give you some information here, we'll say that this side length is 3. So I need you to list all of the corresponding sides, and I need you to tell me what the scale factor is of these similar figures. Sorry the video was a little bit long today. I apologize. I'll work on keeping them short for the rest of the week. Thanks, guys.